In this section, we want to start talking about higher order derivatives. And to start that discussion, we'll look at answering the question, what do we mean by a higher order derivative? We already know that for a function f of x, we can find f prime of x, the derivative of that function f of x. Or if we use some of our alternate notation, we could say d over dx of f of x, or df over dx. Each of those statements means find the derivative of that function f of x. Similarly, for a function f prime of x, we can find the derivative of that function f prime. And we would note that as f double prime of x. Or we could state that we want to find d squared over dx squared of f of x, or d squared f over dx squared, mirroring those alternate notations we have for finding f prime of x. And we refer to this idea, f double prime of x, as the second derivative of our function f of x. And we could continue this process. We could find a third derivative, fourth derivative. Essentially, anytime we have a function, even if that function is the derivative of some other function, we can differentiate again. But we'll stop at just the second derivative. We'll look at a couple of quick examples here, some simple examples. First, we want to find in part A, f prime of f of x, meaning we want to find the first derivative of negative 10. So to find f prime of x, we would be differentiating negative 10. That's a constant term, and we've already established that the derivative of a constant is just 0. So our first derivative would be 0. To find f double prime of x, what we want is the second derivative of our function f of x. And in this case, that means we'll find the derivative of 0, the derivative of f prime of x. The derivative of 0, we still just have a constant, so that result is still just 0. This is a good example to look at because it reinforces a concept that hopefully is more or less intuitive. Once we take the derivative of a function or just an individual term and we get 0, any subsequent derivatives of 0 will just continue to be 0. So once a function or a term goes to 0, we don't have to continue worrying about that function or term. And we'll see how that plays out in example 2, where we're asked to first find d over dx of g of x. What that means is we want to differentiate x plus 6. The derivative of x will be 1, and the derivative of 6 will be 0. So our derivative would just be 1. We don't need to write out that plus 0. And since we know that second term went to 0, subsequent derivatives of that term will continue to be 0. So when we want to find d squared over dx squared of g of x, we only have to look at differentiating 1. And the derivative of 1 will also go to 0.